Okay, so this is my belated lecture for 13.4 for MAT264. We're going to talk about the cross product. And again, this will get us set up well for the lecture tomorrow, where we can then discuss some of the problems on how to find cross product, what it means, and all that kind of stuff. Then what I will do is I will do another video after tomorrow on sections 12.1 and 2, which is more on graphing three-dimensionals and those kind of things. So we kind of backtrack a little bit, but then that will be what we use for Friday. But I wanted about half the lesson is on cross product of vectors, so I want to get this this lesson out and allow us to see how it works. I've also extended homework problems due dates till Wednesday, so if you do have questions we can get those answered. But to get that first start off, since we'll see, hopefully this weekend I will get the new lectures ready so you can, if you have the time, you can view them before Monday, when is really the start of the week, and then we can again go to focusing on the Wednesdays and Friday meetings to answer questions about how to do the problems and any remaining questions. Okay, let's go here, and we're going to take a look at section 13.4, the cross product. So remember, we're looking at two vectors. This is a type of multiplication, and what the cross product is I don't know, it's hard to talk about the right-hand rule without seeing what it is, but we're going to see this in a moment. But V and W are two vectors, and their tails coincide with each other. So you know, you've got maybe V here and W here, and you've got some angle between them because you've only got two vectors that are in the same plane, obviously. And then there's a normal vector that shoots off perpendicular to them. And the right hand rule is you take your right hand and you wrap your fingers from V to W. So in this case, we would wrap in the normal vector would actually be shooting back through the video, because the right hand rule says that it would go that direction in the three dimensions. It's hard to, they have a better picture, so we'll take a look at that. Again, with the cross product, there's two definitions, and it just depends on which one we're going to be, what we're trying to do, that we might use it. So the cross product has a geometric definition, which is once you have the two vectors, you can take their two magnitudes. Now remember, magnitude is a number, and then you multiply it by the sine of the angle between them. So here's theta, and then it is still, it's not just a scalar, it is actually a vector, but it's a vector in the direction of the normal vector that comes off using this right hand rule. So this one, because it goes from V to W, it would be shooting back through the screen, I guess, not out from the screen towards us, but to the screen, because you take your right hand and wrap it down so the thumb, of course it's hard to see from this video, but the thumb would post backwards through your monitor, not out from your monitor. I hope that makes sense. We'll see. So that's one definition. The other one is algebraically. We're going to show how this is really where the word cross product comes from. You'll see that the I component of the vector is the J component crossed with the K, and the K component crossed with the J. We'll break this up, but there's a lot to this, but there's a cross product here, and you take one and then you subtract, and then you do this one and then you subtract that one, and you do this one, you subtract that one, and you get we get what the cross product is, again, which is a new vector, and again it's a normal vector. This cross product gives us a normal vector to that, so it's either going normal to the plane of those two vectors, and it's either shooting, again, if the plane is our monitor, it's either shooting towards us or it's shooting away from us, one or the other. and you use the right hand rule to figure out which the direction of that normal curve. So here's the right hand rule. So if you curl your fingers, your thumb would be sticking upward in the air. If it was the other way around, if V was here and W was there, then it would be going downwards. That's why when we change, you're going to see when we change the order of how we do the cross product, when we change that order, it's a negative. So it's the same vector, but it would be negative if we went from W to V. So if we did W cross V, it would shoot downwards. So this is W cross V. Okay, going downwards. Going upwards is V cross W. Going to see that soon. And then if we take its magnitude, the magnitude of that normal vector, that's actually going to be the area of the parallelogram. So we'll use that for applied product problems. Okay, and here's another one. So going from V to W would be this, and again going down. So just a little bit more. I'm going to use this little figure here on the next slide. I made a new slide with it, breaking it down. So to get the I component of our new vector, so V cross W, it's going to have an I component, a J component, and a K component. Okay. To get the I component, what do? We do a cross product of V2 times W3. Okay, so remember those are the components from J and K, V2, W3, and we'll do an example together, and then we subtract the cross product V3, and again, these are numbers, right? Because those are coefficients that are in front of the vectors, right? Because it's vector V is V1I. Okay, so that is going to be V3 times W2. So downward, backwards. Okay, let's see, and then we're going to add same sort of thing. So for the J, we're going to do I and K. We're going to cross those ones. And in this case, the one that goes first is this V3 and W1. Those get multiplied, subtract V1 times W3. Okay. And then we come here, and to do K, we're going to do a cross product of I and J. And let's figure out how to move over here. See if I go like this. Okay, so you see our V1, W1, sorry, V1, W2. Okay. So cross product V1 to W1, or V1 to W2, sorry, minus V2 to W1. Okay, so we started left to right there. This one, we went from V3 to W1. So you can think of, since we're starting the one to the right, starting with the one to the right, and again, we're starting with the one over here to the sort of the right. If you were to wrap around, the K comes around this way. So we'll, obviously order is important upon which one gets subtracted, which one is the negative one. The I and the K go from starting with the upper V, V2. It's this one in the middle. As you can see, which one does it start with? It actually starts sort of with the W going up to here, and then this would be, so this is the first, and this is the second one, the one that gets subtracted. So J is a little bit different. Okay, let's look at an application. Or let's look at some properties first. Okay, so remember you've got your form sort of a parallelogram here with a theta, and then your cross product is a normal, a 90-degree vector coming up out of there. Then you could use the right-hand rule. Well, and as I discussed, because if we change the order, if we go from W to V, then the normal is going down the other direction. It's the opposite. So that's where this part comes from. So if we change the order, the normal vector is going to go the other direction. Thinking of that right-hand rule, and your thumb becomes the normal. So if you go this way, it goes down. If you go this way, it's going to go up. Okay. Hopefully that makes sense. And then if we've got a scalar, we can multiply that scalar by either of them, or get the product and then multiply it by the scalar. That's just a sort of associative rule, I guess. The scalar can go times any one. And then when we take a cross product over adding 2, so this helps if we're like looking at components, we could, it's the same thing, sort of a distributive property. We could take the cross product of each of the vectors and then add, or we could add and then take it. So there's our distributive property of the cross product. Now, finding the equation of a plane through 3 points. If we've got 3 points, what we do is we turn them into 2 vectors, and notice they both start at one of the same points. Again, you could probably change this, but again, so whatever plane we're going to follow, if we choose a point to start with, and then we're going to go, here's P, and then there's the vector PQ, and then we go from P to R. That's going to form a plane, and those are 2 vectors. One we'll call V, the other W, and we can get its cross product, and that's what we're going to do. But first we have to find these vectors, so we find the cross product. So find the vectors, we again take the X component, subtract, so 3 minus 1, and then since Q is the second one, we do 4 minus 3, it's that one, and then we do, we're still on here, we're starting with the Q1, so Q is negative 3 minus 0, so that comes there, and that gives us, we do the arithmetic, that gives us 1 vector. For R, we do the same thing. So again, we're P to R. We start with R. So this 3 comes from here. The negative 1 comes from subtracting the X coordinate. To get the J coordinate, we start with 6 because that's what's in the R. So 6 minus 3. 6 minus 3. And then the last one will be 2 minus the last, the K coordinate, Z coordinate. It's hard to, the components, okay, and we get these vectors. And now when we go to set this up, notice we've got it set up like this. Let's see if we can match these components here that we come up with. How do we get the I component? Remember, the I component is going to be J times K, so cross product, so it's going to be 1 times 2 minus negative 3 times negative 3, so that's 9. I should maybe just write these, do this in our head, so we get 2, that's negative 9, so that's going to be positive 9. 2 plus 9 is 11, so that worked. Okay, maybe I should erase, it's going to get messy, isn't it? So that's how we get that one. Let's come back here. A new clean slate. For the I component, remember we're going to go from the I times k, but remember it's kind of backwards. It goes negative 3 times 2, so negative 3 times 2 is negative 6 minus 2 times 2. 2 times 2 is 4. Negative 6 minus 4 is negative 10. That worked. Okay, and we'll just do a little erasure. So you just see it's sometimes kind of tedious, but you got to be real careful of placement and everything. So remember, when we do k, we're doing I times j, and again we start with left to right. So this cross 2 times 3 is going to be 6 minus 1 times 2, which is 2. 6 minus 2 is positive 4, and we matched up. Okay, so that's how the cross product. We just got to take our time, go through it. And so what this is telling us is, here's our vector, and since the point 1, 0, 3, this is P, right, is on the plane, the equation of the plane is, and again, I guess we could have chosen any of these other points because they're also in the plane, but this is what we did in the previous lesson. So we take our vector, and the I component is going to be x minus 1, y minus 3, z minus 0. We distribute through, we get 11x, negative 10y, 4z, which is the normal vector we've got here. And then from distributing, we got negative 11, we get positive 30, and then we get 0. So there's negative 11 from 30 is going to give us positive 19. Subtract that from both sides, and that's where that negative 19 comes. So getting the equation of a plane. We'll look at another one. Why not? Since this was kind of our scaffolding, they did it for us, and we just kind of checked as we went through. So let's see how we do as we give one a try on our own. We got 3 points, and again, what we're wanting to do is the question that was posed is find the equation of the plane. So what we're going to do is, again, we're going to go from A to B. So that'll be one vector, and then we're going to go from A to C. Now you can try me. The 3 points form a plane, so you should be able to get the same plane regardless of which ones you go from, but we'll give it a try. Okay, so vector AB. Let's see how I do without the scaffolding. So what we're doing is we're going to get our I component is going to be B minus 9. So the B coordinate is 11 minus negative 9. I'm going to write it this way so we have a record of what we're doing. Plus the J component, and I get tired of writing those little vectors on top, but probably shouldn't, is going to be 10 minus 11. And again, you might, as you do these, go ahead and do the arithmetic in your head, but I like to keep track, as if we make an error, it's something I like to keep. So then 12 minus 0. And so that you know where my values are coming from. My numbers are coming from. 11 plus 9, that's going to be 20i. 10 minus 11, that's going to be negative 1, or just negative j. And this is going to be plus 12. Okay, so there's one vector. Now let's get the other vector, C, AC. So we start with C, so that's going to be 9 minus negative 9. I. Negative 9 minus 11, J. for the k component, we're going to get 13 minus 0. So AC is going to be 18I minus 20J plus 13. Okay. So those are our two vectors, here and here. To get the equation of the plane, we do the cross product. And then we do the point A with XYZ. Okay, so cross product. And we'll come over here. I might need an extra page, right? So we've got I, J, and K components. So let's set it up more as a matrix, it says. And then the second one is going to be 18 minus 20 and 13. Okay, so that's our matrix. And when we want to do AB cross, right, we're looking to do vector AB crossed with AC. Okay, so our I component is going to be the J, so it's going to be negative 1 times 13, going to be negative 13. Oops, getting ahead of myself. I can't really, there's a couple calculations in this. That's what makes this more difficult. So that's, remember, that's going to give me negative 13. That goes first. Then I'm going to subtract this cross product, 12 times 20. That is going to be 240, a negative 240, so that makes that plus 240. 240 minus 13 is going to be 227. Okay. So for the J component, again, we do the cross products, but again, remember, this is the one that's kind of backwards. We start with K, so we go 12 times 18. We have all these larger numbers. So I could do it with my handheld calculator, but the problem is when let me keep these. When I make a mistake, as often happens, over here. There we go. You don't know that I made the mistake. At least if this way, if I make a mistake, you'll see that it's a mistake. Let's go back to the slideshow. There we go. I guess I better go over here. So I want to do 12 times 18. And maybe this will help. So we're doing 12 times 18. Actually, it's kind of a nice way to do it. Then we don't have all this stuff here. And then I do 13 times 20. I'm subtracting 13 times 20. Subtract 13 times 20. Now, order of operations will be followed by my calculator, so I can be safe about this. Gives me a negative 44. So minus 44J. Okay, so what did I have? Maybe I'll 12 times 18 minus 13 times 20. Again, it's just good to have this for backup work in case I go, oh wait, I did something wrong here. It didn't work out. So then let's do our K, right? K is going to be I times J, and again, it just 20 times 20, or 20 times negative 20. Oops. And then we subtract 20 times 20. negative 1 times 18, so subtract negative 18. Okay, so that's going to give us a positive 20 times 20 is going to be 400, negative 400, and this becomes plus 18, so it should be about negative 382. Wow. So that's our vector. What we do is we put in, let me give myself one more, get out of here. I'm going to give a new slide. Back to the slideshow. Okay, so 227, 444. Maybe I can work it here. It's going to be easier if I do it. So then again, to find the equation of the plane itself, I take my point A, and the component here, I, is now going to be, back on the last one, it's like what's happening here. Notice the I became X minus the point, Y minus the point, Z minus the point. Okay, so coefficients are there from the variable. It's all equal to 0. We do this, we're going to do some distributing. We'll get a number, and then we get the opposite number on the other side because we either added or subtracted it, right? Okay, so we're going to have 227 x minus negative 9 minus negative 9. Well, we could leave this negative 44. The j component is y minus 11. And then we've got our minus 382, and k is going to be z minus 0. That all equals 0. So we do the math. This is x plus 9, so we're going to end up with 227x. I'm going to put the plus 9, it's going to keep track of, well, plus 9 times 227, right? Let me, how do I get my calculator? Extra one anyway. So we want to do 227 times positive 9. It's going to be 2,000. Where should I put that? And we're going to get negative 44 times y. 44. And then 44 times 11, negative and negative, so that's going to be a positive number. 484. I'm going to just check it. I'm pretty sure it's 484, but it's 484. Doesn't hurt to. And then the last part here, let's move our thing out of the ways. It's going to be a lot easier. It's just negative 382 times z, and then times 0 is 0. So don't even need that calculator. Well, we might need it later, but minus 382z equals 0. And then we just take our numerical parts here and here. They're like terms. We can add them together. They're both positive, and then they're going to, so that it'll be minus on the other side, and then you'll see your plane is 227x minus 440y minus 382z. And what do we get on that side? 2043 plus 484 gives us 2527. So $25.27. So let me just, actually I'll write the final answer up here. 2527 is positive. We bring it over, so it's going to be the equation of the plane will be equal to negative 2527. Put that down, and then these components: 227x minus 44y minus 382z. So again, and you see this is a homework problem. I think when you do it, the numbers will change a bit, so you'll be able to check that out and give it an answer. But that's the process. We have to make the two vectors, do the cross product, and once we have that cross product, we turn it into the equation of the plane by combining the vertex point with the point x, y, and z, that component for any general one in there. Okay. Skipping that. And then we're just finally, what does it mean? Well, when we take a cross product, when we get the area of a parallelogram is the magnitude of the cross product. And remember that magnitude is actually the vector we end up with. I guess I should use the right hand, is the normal curve, but that magnitude represents the area of the parallelogram. So the greater the area of the parallelogram, the greater the magnitude of the normal curve. And then when we have three dimensions, we can talk about a parallelepiped, if I said that right, with vector edges A, B, and C getting into three dimensions. It's the cross product. The volume is the cross product of B times C times 8, and so A is acting like the height. So it's the cross product gives us a two-dimensional parallelogram. If we're dealing with three dimensions, that third dimension is the base, the area of that base times the height. And we've done that before, but this is using vectors. And if I click one more time, this PowerPoint's finished. So that gets us enough to be able to get in and dig into the various questions that we have. So then do your best to get a little bit of start on this portion of the homework. We'll look at answering some questions on class on Wednesday, and we'll see if I can't get this started a little bit earlier. But again, your input is always helpful. Let me know what helps and what doesn't help. And I try to set my personal feelings about good or bad or indifferent. You're the judge. If it helps you, then it's good. If it doesn't help you, it's not good. So I've got to adjust. Okay, so that's my goals. Is just give me clear input. Don't worry about, oh, he's the teacher. He's, I'm just trying to help you learn. If you learn, you're going to be fine. Not if, you're going to learn, right? You got to learn. We got to learn together. So keep up the progress. I'll stop it here, and we'll be in class and continue working through some problems. Thanks.